Hello, fellow mathematicians. Here are your notes for lesson 8.5. And we're going to be comparing linear and exponential and quadratic functions. Okay, so we've learned about linear functions, we've learned about exponential and quadratic functions, and now we're going to compare them. So first, let's start with linear functions. Alright, so we're going to go way back. We actually learned this in pre-algebra. So linear functions, when you graph them, they will always be a line. Okay? So when you graph them on the x and y coordinate plane, the xy coordinate plane, it will always be a line. So it'll be nice and straight. Now, sometimes it runs diagonally uphill like this one. Sometimes it might run downhill. It could run horizontally. It could run vertically. But it will always be a line. All right. The table is next. So here would be an example of a table that comes from a linear function. Let's say you have 0, 1, 2, 3, 4. And on the other side, let's go 4, 6, 8, 10, 12. Now in a linear table, what you'll need to do to see if it is indeed linear is check the change in the x and the change in the y, and both sides need to be constant. So here, the x values are always changing by 1. They're always going up by 1. And the y values are increasing by 2 every time. And it's an add. The x values are adding, increasing by 1. The y values are adding by 2. Now it could be adding or it could be subtracting. That would be a linear function. Okay? And that actually helps you find the slope. So how you actually say that is the y values. The y values have a common difference of 2. They add 2 every time. All right. Then the equation will be next for a linear. So let's do equation. So we talked about the graph, a table, and now the equation. An equation that we studied the most, or used, I thought was the easiest, was y equals mx plus b, slope-intercept form. And remember, m stands for slope, and b represents the y-intercept. And it's easily found from this table. So if we use this example here in this table, all we'd have to do is go y equals And the slope, if you remember, slope is the rise, which is the change in the y, the rise over the run. Remember, rise over run. And rise is how much does the y change every time? How much does it go up or down? And the run is how far does it go left or right. So in this problem, the slope is 2 over 1, and then x plus, and b is the y-intercept. And remember, a y-intercept is always when x equals 0. When x equals 0, there's your y-intercept, so it's 4. And so a better way to write this would be y equals 2x plus 4. So this side here is the rise, what the y changes by. And then over here we figured out the run. What did x change by? Okay? Alright, now let's do the exponential functions. That will be in the next video.